Let's take a look at another Windows control container, and that would be a list box. So let's experiment around with that a little bit. So we'll go into Visual Studio and we will create a new project, and that will be a Windows Forms app, and that will be a demo of a list box. All right, so a list box is basically a way to, as the name implies, create a simple list of something. So we go into Toolbox and we look for List Box. And here it is. Double click on that, and that creates this box as you see here. And there are a number of fairly standard operations associated with list boxes. So let's just do a couple of them. Of course, the first thing we'll want to do is to properly name this. So we'll call this list box, let's say car or cars. All right. So let's go ahead and run this, and we'll go over here. We'll make this property or this project the startup project, and then run the code. And as you can see, by default, the list box is empty. It has nothing in it. So we want to populate that, and there's a number of ways to do that. Let's go back to the properties associated with the list box. And we see these here. And in fact, the first one is items. That's the one that you see highlighted there. And let's go ahead and click on the ellipsis. And that brings up something to some set of strings to put into the list box. So let's say Pinto and Maverick, Lynx, Cougar, something along those lines. Okay, so we click OK. And we will see that those are populated into that list box. If I were to run this now, you would see Pinto, Maverick, Lynx, and Cougar all show up. So that's one way to populate the list box. And if we look for the code behind that, as before, we can go into the designer code here. And you will see in the designer part, there's that list. Okay, so that's one way to populate the list box at what I would call design time. We can also populate the list box as part of the first event procedure executed in the when you run the Windows application. So in other words, we could go back to the form here and look at the properties associated with the form and go to the events part of that. And what we're looking for is load, and there it is. I could double click here and it would open up a stub for that. Or the quick way to do this is just on the form itself. If you double click, I'm going to double click right here on the form itself, and that opens up the form load event procedure. And so then you put in the name of the list box. And so there's list box cars, and I can say add. This is a common mistake to make. You see, you sort of think of it as adding to the list box itself. But it turns out that there is no add property associated, or there's no add method associated with list box or an object of list box. So you have to add not to the list box itself, but to its items property. And then you can say add here. And I can put in some more car names or whatever strings I might like. Like so. And so this, of course, this piece of code would be executed at the beginning of runtime. And what I mean by the beginning, I mean before the user actually has access to the control. So let's go ahead and run this. And there you see that not only the design time values of Pinto, Maverick, Lynx, and Cougar, but also the runtime values of Falcon and Mustang are placed into the list box. Now let's consider some other possibilities, some other things that you can do with list boxes. So again, list box, and always items. And you've already seen add, and the opposite of add is remove. So for example, Falcon, because that one's there. And by the way, if you attempt to remove something from a list box that doesn't exist, it's a non-operation or a no-op. So for example, I could say list box cars, items, remove something that doesn't exist, and this is not an error because that doesn't exist. It will simply not do anything. There's also a remove at, and this takes a specific index. So for example, I could say remove at index 2. All right, and that will remove the third item. So it starts at 0, so 0, 1, and 2. It will remove index item 2. This one you have to be a little more careful with because you have to make sure that there's actually something to remove. So for example, if you were to say remove at 100, we clearly don't have 100 items. This would result in an error. This would be a runtime error because there is no such thing as item 100. So I'll go ahead and comment that out. But that's the difference between remove and remove at. Remove with something that doesn't exist is fine. Remove at with something that doesn't exist will result in an error. And just a couple of other simple ones. You can also get the count, which is to say the number of items. So for example, if you did want to remove the very last one, you could use the count property, which is actually capitalized. You could actually use the count property to determine whether or not remove at would be possible. Because if there isn't that many elements, then clearly you can't do a remove at from that location. And also notice that things will be moved up by 1. So if you say remove at, say 2, which as we've done here, which is more or less in the middle of the list, then everything below 2 will be moved up by 1, and there will be a new item at index 2. So for example, I can put the count here, so let's do a message box show. And that has to be a string in order to put it out to a message box. And there's a message box dot contains. So we say list box cars dot contains. Again, let me caution you, you can say contains, and there is actually a method called contains. If you look at the properties or the parameters associated with the method, though, you see that it takes a control. So again, we don't want to mess around with the list box itself. We want to manipulate the items in the list box. So unlike add, which didn't even exist for list box, there is a contains, but it's not the one you want. So again, what we're looking at doing virtually every time you play around with a list box is you want the items property of that list box, not just the list box itself. So anyway, we can say contains, and that allows us to put something in that we think might be there. So for example, let's try Pinto. Okay, and let's go ahead and write that out to a message box itself. This will contain, or this will return a true and false indication. So let's see what happens to us. And once again, I need the show method, like so. And once again, that needs to be converted to a string in order to write it out to a message box. All right, so we have enough code there. Let's go ahead and try to run this. And again, note that this will all take place before the user has any opportunity to manipulate that list box because it's in form load. All right, so we run the code. And we see the first thing that we get is the 4 that indicates the count. So the index values of those 4 items would be 0, 1, 2, and 3, and the value of count would then be 4. And if I click OK, true indicates that, in fact, the string Pinto was found in the list box. In other words, this one right here was found in the list box, and therefore it says as a return value true. And based on that modification, we have Pinto, Maverick, Cougar, and Mustang. Falcon was removed as a result of this call right here, and then later the item at 2 was removed as a result of this call. And then one other item that will allow us to manipulate a list box. Let's take a look at the design. Go back to design here and put a button on here. Double click on the button. And now I have a button. And if I'm not even going to bother to name this thing because I'm just going to give it some code. Double click on this button. And there's my event procedure for that button. And I can say listbox cars.items add, and let's say Tercel. And just to show that we can do a couple of different things, let's also listbox cars items remove. And let's see, we know that the Pinto is there, so let's go ahead. So we run this code. And of course, we still have the count and the fact that the Pinto is there during the form load. And then we have our list here as before. And if I click button 1, of course, it's going to remove Pinto and it's going to add Tercel. And that's what has happened. So Pinto is removed from the top and Tercel has been added to the bottom. So in net, we still have 4 elements, but they're different 4 elements. Now, if I were to execute this again, it would attempt to remove Pinto, which isn't there, so nothing will happen, and it will add another Tercel. And so that's exactly what happened when I clicked on the button. All right, so let's close this down and just briefly take a look at the provided demo. So here's that provided demo, and as you can see, it is called Grocery List. And so let's just run that real quick. So here's the grocery list builder. And we can add things by typing into the text box. So we can do that. And we can remove things in the same way. So for example, if I wanted to remove milk, I could type in milk and then click remove, and milk disappears. Or I could remove a particular selection. So for example, peanut butter and carrots, let's say. So I hold the shift key down, just like a lot of standard controls. Let me start over with that. So there's peanut butter is selected, or eggs is selected. I'll select peanut butter, and if I can hold the control key down, then it does a discontinuous selection. Or you could click peanut butter and hold the shift key down, and then it does a continuous selection. So in this case, I just want peanut butter and carrots to be removed, and so I click remove selection, and then they go away. Or if you know the specific index involved, 0, 1, 2, 3, you can select that here. And notice it is possible to go above the number, but of course you could add controls into your code that would not allow that to happen. I'm not going to do that here, so I'm going to go back down to index 2, so that's 0, 1, 2. We expect eggs to be removed, and sure enough, that's what happens. And if I wanted to clear the entire list, like so. So let's just take a look at that code briefly. And there we see the list of items add, and that's done at form load time, so that's before the user has control of the form. And then there's the add click, and as you can see, it takes the text from the text box and does an items add, like so. The remove, again, takes the text from the text box and calls items.remove. Here is the list of selected indices, and we are looping through the list of selected indices to select all the indices that were selected. And notice that it does go in reverse, because if you went in the forward direction, it wouldn't remove as expected, because every time you remove something, you would change the index of everything else. And then we have the event procedure for using the remove at index, which instead of being a loop, just simply make sure that the index is actually available, and then removes at that index value. Notice I did have to get the numeric value of the up and down, or the numeric up-down control and convert that into an int in order to use it as an index. And it might be worth going ahead and showing that behavior. I didn't show it at first, but since we're controlling for it, so here is what that would end up looking like. So we have the index 0, 1, 2, 3, 4, and 5. So if I were to, for example, attempt to remove 3, 0, 1, 2, 3, it removes milk. If I were to say remove it 3 again, now eggs is 3, it would remove that. But just for the sake of just demonstration, let's put a number there that's clearly beyond the possible remove at index and click on that. And then if you go to the output window, you will see that the error to attempt to remove something as an index which does not exist gives you that debug message. And of course, you could also write that out to a message box window or any other way you wanted to alert the user. In this case, we're basically just doing an internal message for the purposes of development. So we'll now close this application. And that's the discussion of ListBoxes.